Hi, welcome to my video on inverse trig functions. Next series of videos will be on the inverse trig function, and this one right now is on arc sine. It's the inverse of the sine. So the sine function, so let's look at the sine function and its inverse. So we have a circle, a unit circle, and the radius of the unit circle is 1, so this is 1. So 0 degrees, x is 1, y is 0. 90 degrees, x is 0, y is 1. 180 degrees, x is negative 1, and y is 0. And 270 degrees, x is 0, y is negative 1. So from this rotation, I'm going to draw the sine graph. And we have theta and y equals sine theta. So at 0 degrees, sine is the y, cos is the x, so sine is the y. At 0 degrees, I have a 0. And at 90 degrees, the y is 1. At 180 degrees, y is 0. At 270 degrees, y is negative 1. And at 360, y is 0. So this is the sine graph. It's a sideways S, seen that before. And remember, I reviewed the trig functions, and I reviewed it because I knew I was going to do the videos on the sine, cos, tan, secant, cosecant, etc. And so this continues down to here, down to negative 1, then it goes up to 0, and so this is the sine graph continuing on and on and on. Now, we want to look at the inverse of this is a function because it passes the vertical line test, but it's not a one-to-one function. In other words, I'm going to draw a horizontal line. If I draw a horizontal line like this, it will pass through the function at many points here and here and here, and again it continues on, so there's many points that the horizontal line will pass through. So it's not a one-to-one function. So in other words, the sine graph fails the horizontal line test because the horizontal line goes through many points. So what we have to do is that we have to restrict the domain. Now, to get further information on this, you should look at the inverse functions and look at the horizontal line test, because there's a whole unit that I've done in pre-calculus on inverse functions. So we have to restrict the domain. So how do I restrict the domain? Well, I'm going to take this point right here and this point here, and I'm going to look at this part of the graph. So this part of the graph is going from 90 degrees, and y is 1, and it's going from 90 to a negative 90 in degrees. And so we have, this is a negative 1 here. So it's going from 90 to a negative 90, and so the values of y go from negative 1 to a 1. So the inverse again is when you switch the ordered period, because this is a reflection in the line. If you drew the line y equals x up through here like this, and I'll draw that line. This is the line that y equals x. So that's y equals x. So if you reflect this part of the sine graph in this line, the 90 and 1 becomes 1 and 90. So what happens? This becomes 1 and 90 degrees, and this negative 90 degrees and negative 1 becomes negative 1, negative 90. So the graph goes like this. That's its reflection in that line. And I want to show that reflection another way. That's one way. So before I do that though, let's say you have 60 degrees. There's 45. Let's say 60 is right here. So the sine of 60 is 0.866, almost a 0.9. So the inverse, when you do the inverse of this point, you get 0.9, which is here, and you have a 60, which is here. So the graph is coming down this way. But again, I have developed a grid. Here's the grid. So notice this grid right here. I have reproduced it on this grid here. So when you do a reflection in the line y equals x, so you have a pretend line. So if you take this grid and pretend this is the line where my pen is, this is the line that's y equals x. Okay, move that. So what I do, or what you can do, is pick up the grid like this and reflect it. So I'm going to rotate it with my fingers. Watch now. I'm going to reflect it. So pretend the tips of my thumbs are on the end of the line y equals x on each end. So when I rotate it, reflect it, I'm reflected in the line y equals x. I turn it over, and there's the reflection. So that reflection is, notice I'll show you, the domain, let me look at it this way, right here. I'll move that up. The domain and the range are switched. So the theta goes up with the y, and the y goes down with theta. So the domain and range are switched around. They're the inverse of each other because of the reflection in the line. So I wanted to show you that reflection the way I do it. So as a result, this is the restriction. So the domain here, the domain is negative 90 to a 90. So the domain is negative 90 less than or equal to theta less than or equal to 90. And the range, the y values, is negative 1 less than or equal to y less than or equal to 1. So you're restricting it. Again, the theta is from negative 90 to a 90, and the y's are from negative 1 to a 1. So when you reflect it, your domain and range, so your y's are negative 1, your domain becomes, your range here becomes your domain, and your domain here becomes your range becomes your domain. So this domain is your range, so it's reflected in the line y equals x. So the domain and range are switched around. So this is the y's. So as a result, we have theta is equal to sine to the negative 1 on the y, or theta is equal to arc sine on the y. So arc sine and sine to the negative 1 is, so this graph right here is theta. So notice the y value is here, and you're looking for the values of theta. So it's switched around. Again, y sine theta, sine inverse of y becomes theta. So they're switched. This is domain, this is the range, this is the domain, this is the range. So they're switched around. Okay, let's turn that over, hopefully, and you have to see this restriction and how the inverse is done. Okay, what I've done now is to do another series of questions related to that. I have, notice, this is the reflection. So this point here is 90, 0, 1, and this point here is negative 90, 0, and negative 1. So you can only, when you're doing an inverse, you can only pick. So what happens, again, with an inverse is, just look at it. If you look at the sine of 30 degrees, you're going to get a number. But when you look at arc sine of a half, then you're going to get an angle. So the sine of an angle is going to give you a number, but the arc sine of a number is going to give you an angle. So they're switched around. Okay, the sine of 30 degrees. Let's look at a triangle. So we could draw the triangle two different ways. We can have a 30 and a 60. So it depends on which way you want to do it. You can go 1 root 3 2, where the hypotenuse is 2, and opposite 30 is 1, and opposite 60 is root 3. Or you can have your hypotenuse as 1, and opposite 30 is 1/2, because it's the adjacent over the hypotenuse. And you got root 3 over 2, so you can have either one of these. I'm going to use this one, because when I get the tan and secant or cosecant, this is the better, simpler one to use. So 30 degrees on my triangle, on the rotation, 30 degrees is roughly right here. So if you draw a terminal arm, draw a perpendicular to the x-axis, that's your 30-degree angle. So this 30-degree angle, this is the 1, this is the 60, so this is root 3 into 2. So the sine of 30 is opposite over hypotenuse, so it's 1/2. Now, let's do a rotation of 150. So 150 is 90 plus 60. So 150, let's say, is rotate right to here. So when I rotate all the way around to here, hit 150, you draw your terminal arm, drop your perpendicular to your x-axis. Because that rotation is 150, that means this reference angle is 30. This is a 60. Opposite 30 is a 1. Opposite 60 is root 3. And this is a 2. Remember now, this is not a unit circle. This is the easier way to figure out the values of the trig functions using 1, root 3, and 2, because you don't have fractions. So the sine is opposite. Now, because you're in the second quadrant, the hypotenuse is always positive. The y is going up is plus, and the x is on this side is negative. So the sine of 150 is equal to the sine of 30, which is 1/2. Now, I have two, each of these is a half, but when you do arc sine, you have to pick, because you have a half is right here. So you have to pick this angle here. So when you pick a half, you have to go to here. So that means the angle is between 0 and 90. So the answer to this between 0 and 90 is 30 degrees. And if you want to do radians, again, I look at degrees first and I change it to radians after. Pi over 6. So I go 30, then I change it to radians. And to change to radians, you multiply by pi over 180. 30 into 180 goes 6, so because of pi over 6. So I'm going to do angles in degrees all the time. Now, we got the sine of 225. Again, 225 is, and I'm going to use 225 is a 45. So let's plot it on the circle first. So 225 is 180 and right to here. So there's 225 right to here. You draw the terminal arm. You pick up your perpendicular to the x-axis. So that's a 45 because that's 180 plus 45. So this is a 45. So this triangle, I always go 1, 1, root 2. So this is a 1, this is a 1, and this is the root 2. So, and again, the x is negative and the y is negative. So the sine is opposite over hypotenuse. So it's a negative 1 over root 2, and we've rationalized it negative root 2 over 2. Remember, you multiply root 2 over root 2, top and bottom, and it becomes negative root 2 over 2. Now we got the sine of 315. Sine of 315 is all the way around. That's 370 right to here. So this is 315 rotating right to here. Draw your terminal arm perpendicular to the x-axis. And again, you have a 45. So 315 and 45 is 360. So this is a 45 right triangle. So this is a 1 because x is positive. This is a negative 1, and this is root 2. And again, the sine of 315 is the same as the sine of this 45. It's a negative 1 over root 2, which simplifies to negative root 2 over 2. Now, what about the inverse, working backwards? I got a negative root 2 over 2. Now, a negative root 2 over 2 is a negative 0.707. So negative root 2 over 2, the negative number is right here. So any number that fits in here, you have to pick up the angle going along here, which is between 0 and negative 90. So any number that's negative for sine, the angle is going to be between 0 and negative 90. So that means this end, you can't take 315 because it got to fit, the angle has to fit between 90 and negative 90. So this has got to be a negative 45. Because the rotation of 315, this is 45 here. So if you went from here to here, you get a negative 45. Hopefully, you have to pick this. This is inverse right here. So if it's positive, it's between 0 and 90. If it's negative number, it's between 0 and negative 90. Now, let's do a few more to illustrate that. We have the arc sine of root 3 over 2. So root 3 over 2 is in the 30, 60, 90 right triangle. So that's a 30, that's a 60. 1, root 3, 2. So root 3 over 2 is the sine. So if you look at the sine of 60 is opposite. So the sine of 60 is opposite over hypotenuse, which is root 3 over 2. So the sine of root 3 over 2 is going to give you a 60, or it's going to give you a negative 60. Root 3 over 2 is positive, which is root 3 over 2 is 0.866.9. So 0.9 is right here, you go across, and the angle is right here. So it's a 60. So the angle is a 60. Because it's positive, you had to pick the angle between 0 and 90. Now, remember, root 3 over 2, root 3 over, sine is positive. According to the add sugar to coffee. If you add sugar to coffee, sine is positive in first and second. So sine is in here and sine is in here. So if you got root 3 over 2, you have a 60, or that's a 60 to far as here, or you have 120, which is far as here. So there's the 120, there's a 60, but you can't take 120 because it's too big. You got to pick it between 0 and 90. So the answer is 60, and 60 is pi over 3 when you simplify it to a radian. Okay, now we have the arc sine of a negative a half. Again, a negative a half fits in here. And we got to add sugar to coffee. So sine is negative. So sine is positive in 1 and 2, negative in 3 and 4. So sine is negative in these two. So we draw up a right triangle. Remember, I use add sugar to coffee. All, sine, tan, cos. These are the positive ones. And so we have negative a half. So we have the angle of, look at this triangle now. So we have, that means we got sine is, this is a 30-degree angle. The sine of 30 is a half. So this must be 30 and 30. So let's see. This is 1. This is 60. So this is a root 3. This is a 2. And so sine, because it's has to be 30 to get the sine of a half. So this is negative and this is negative. So the sine of, so one of the answers could have been 211. 30 here, that's a 90 plus 30, or sorry, 180 plus 30 is 210. Or we could be here, so we have 360 minus 30, so we could have a 330 degree angle all the way around. So this could be 330, but sine is a negative a half. So sine is a negative a half, and negative a half is right here between. So there's 0, there's a negative 1, so negative a half is here. So that means the angle must be negative. So we can't have 210. We can't have 330. So we have to take the negative angle. So the negative angle has to be a negative 30. And again, a negative 30 translates into a negative root 3 over 6. Sorry, negative pi over 6 is root 3 over 6. Negative pi over 6. Again, negative 30 degrees multiplied by pi over 180. You cancel the 36, so it's a negative pi over 6. And again, 60, convert 60 degrees times pi over 180. 60 goes into 183 times, so you get a pi over, if you want radians. Now, I want to illustrate, I want to show you something now on the calculator. The calculator will do all this too. So I'm going to do the inverse sine of root 3 over 2. See what the calculator is going to give. So I'm going to turn on the calculator. I'm going to do the inverse sine. Oops, that's the inverse cos now. Inverse sine. Root 3 over 2 is 0.866. So it's 0.866. So what's that going to give me? Because the calculator gives you the correct answer. Notice you have 59.999, which is the 60. Now, what about if we have the inverse sine of a negative a half? So let's clear that and go inverse sine of a negative a half. So it's a negative 0.5. And the calculator is always correct. And it's a negative 30, which is what we have. So the calculator will give you the answer. But remember, when you're doing tests and that, are you allowed to have the calculator? If you are, then you can get the inverse on the calculator. Okay, now what about the arc sine? Sine to the negative, up to negative 1. So negative 1 is right here. And that negative 1 is a negative 90. And a negative 90 is negative 90 times pi over 180. 90 into 180 goes 2, so it's a negative pi over 2, if you want radians. And sine is 0. Sine is 0 right here, so that's 0 degrees. And just to check the calculator, let's check the calculator on the inverse sine of a negative 1 to see if we're right. So let's clear that. Inverse sine of negative 1. And it gives us negative 90. Perfect. And what about the inverse sine of 0? And that gives us 0. Perfect. So hopefully that helps you understand about the inverse. A lot of students have trouble, but I'm trying to make it explain. Again, notice the sine of 30 is a number. This is an angle. This is a number. When you do the inverse, arc sine of the number gives you an angle. Just keep that in mind. So that brings us to the end of the first video, which is arc sine, and we have 5 more to go on the other functions. Again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.